I think I am live now. Can anyone confirm if audio and everything is fine before we get started? Like I was able to solve only 7 problems, so I would mostly discuss 7 problems only. Hello. Like virtual contest is a way to take part in past contests as close as possible to participation on time. It is supported only ICDC mode for virtual contest. If you have seen this problem, a virtual contest is not for you. Solve this problem in the archive. Like, can anyone confirm if audio and everything is fine before we get started for today? And like, only like I will mostly discuss these 7 problems only. Hello, like, and like, how many problems were you guys able to solve in today's contest? Like, that will give me a rough estimate, like where I should focus more, and like where like we can probably move on. Okay, thanks everyone. Like, looks like audio is fine, and yeah. Okay, 2, 3, 2A. Okay, looks like some people. Okay, looks like a lot of people were stuck on the third and fourth problem from the chat. Like the majority is on like solving 2 problems and solving 3 problems only. So like I think with that we can get started. Got PLE on 4. C is one of the most confusing problem. Like we will discuss today's, like I will generally discuss the problem statement as well before moving further over. So like it looks like people are there with 5 problems as well. But yeah, like so I think we can get started now. Like let me just see if my whiteboard looks fine before. Okay, looks like yeah. So let's start for today's contest. First problem statement says where is problem generator. Where is planning to hold rounds next month. Each round should contain one problem of difficulty levels A, B, C, D, E, F, G. Vlad has already has a bank of n problems where the ith problem has difficulty level of AI. There may not be enough of these problems, so he may have to come up with a few more problems. Vlad wants to hold as co- come up with as few problems as possible. So he asks you to find minimum number of problems he need to come up with an order to hold m rounds. For example, if you want to hold m round and he has 10 problems B, G, E, C, D, and like etc., then he needs to come up with 2 problems A and F, because you can see like there is no problem with difficulty A, there is no problem with difficulty F. So like I do any question any questions on the problem statement first, like before I move to the solution for this problem. Okay, assuming like people do not have question, like the idea is for each problem we can count how many times it appears, how many exists right now, and if that count. Okay, so the idea is like for each problem count how many problems exist, and if this count is less than n, then we need this number of more problems. Or like the other way can be like we know that we need 7 into m problems, and yeah, like essentially this is what we can do. And like the code to look at it would be like the idea is like all the characters from A to G are continuous. So if we do like C minus character A, then for A it should give us 0, and for G it should give us 6 over there. So that way we can maintain a vector of size 7. And like whenever we find a particular problem, we can keep subtracting the count over there. So like I start with like n and m. I need 7 problems of m type each. I take input string as input. And if I take like what is the current index of the problem, and if I need at least one problem of the current index, I reduce that count by 1. And at last I take sum of all the values. Like accumulate does this, and like the other way to write it would be this one. So like this can be one way to solve this problem. And like there can be other variations of solving the same type as well. Like any questions on this one? Like the other way to solve this problem would be like we start with counter 0, and like we keep adding like all the problems we have. And when I iterate on this problem, if current number of problems are more than equal to m, I don't need to do anything. Otherwise I should add m minus x, like the required difference count here. I will move to next problem. And like if there are any questions, I would take them from the chat after this, after I'm done with the second problem. It says choosing cube, Dimitri has n cube numbered from left to right for 1 to n. The cube with index f is his favorite. Dimitri threw, I hope I am pronouncing the name correctly. Dimitri threw all the cubes on the table and the ith cube shows value ai. After that, he arranges the cubes in non-decreasing order of their value from the largest to smallest. If two cubes show the same value, they can go in any order. After sorting, Dimitri removes the first m cube. Then he became interested in whether he removed his favorite cube. Note that the position could have changed after sorting. For example, if this is like second cube is his favorite and he has 5 cubes, 4, 3, 3, 2, 3. Then after sorting, the array becomes 4. Like sorting array becomes 4, 3, 3, 3, 2, and like his favorite cube can be at any position. So like the idea over here is we need number written on our favorite cube, or like basically first the problem statement. It says we have multiple cubes which have different numbers written on it. Let's say 3, 2, 2, 4. Now we should sort them in decreasing order. Let's call it A, B, C, D. Like one way to sort them in decreasing order would be D, A, B, C. The sorted order would be 4, 3, 2, 2. Another way to sort them in decreasing order would be D, A, C, B. Again the order is 4, 3, 2, 2. Like notice that values which are equal, there can be any order between them. And the next thing it says, let's say we remove 3 cubes now. Let's say we remove first 3 cubes. And let's say our favorite cube is B. Now if this is the order, when we remove first 3 cubes, our favorite cube would be removed. But if this is the order, then our favorite cube will not be removed. So answer in this case is maybe. Here removed, here we have not removed. So any questions on the problem statement? Any questions on like the second problem? Okay. So moving to the moving further, the idea is we first need sorted descending order, and like we also need number on our favorite cube. And let's say like this is the sorted order of our cube. Like let's first corner cases, if we remove all the numbers, then the answer is definitely yes. So now we will assume that there some cubes remain over there. Now let's say we have removed the boxes in green, and FP is the value on favorite cube. So if we look at like FP is greater than value on this cube, then like there exists an order where we will remove it. Our favorite cube. And if FV is less than equal to BK, like basically FV is less than equal to this value, then there exists an order where favorite cube will not be removed. So like we have basically two conditions. FV greater than equal to BK minus 1, order exists. FV less than equal to BK, like assuming zero based indexing, there exists an order where answer is no. And if both of these conditions hold, we should print yes. Explain the 10th case of the first case. Okay, yeah, I can take that as well. Okay, this is the one, right? Just give me a minute. We have 5 cubes. Cube 1 has 2 written on it, cube 2 has 2 written on it, cube 3 has 1, 1, 2. These are the 5 cubes. Our favorite cube is 2. This is our favorite cube. And we remove k equal to 3 cubes. Then like now if you see the sorted order of these numbers first, it would be 2, 2, 2, 1, 1. And like our favorite cube can be anywhere here. It can be here, it can be here, or it can be here. But irrespective of where it is, we would be removing these 3 cubes. So our favorite cube will definitely be removed. And that's why the answer is yes here. And like that is the idea here. Like let's say like we remove k cube. K equal to 2 cubes. The sorted order would be like decreasing order would be 2, 2, 2, 1, 1. Our favorite cube can be here, our favorite cube can be here, our favorite cube can be here, any one of these positions. And like we would be removing this. So if it's here or here, the answer is yes. If it's here, the answer is no. That's why the answer would be maybe here. And like that is the idea. Yeah, like I will go to all problems. Like just give me some 5-10 minutes for the first 2 problems. Like there are people who might not understand like our structure. Yeah, like speeding up to 2x, like the only way is after the stream. So maybe condition is like a cube minus 1 is less than equal to favorite number, and a cube is greater than equal to our favorite number. Yes, otherwise no. And essentially like this would be the solution. Like if favorite value number is greater than equal to k minus 1 number, then there exists an order where the favorite value would be first k minus 1 number. Yes, live stream will be saved in this channel. And if favorite value is less than equal to k plus 1 number, like less than equal to k plus 1, then there exists some AB as well. And essentially like that is the solution. Any questions on problem B before, any questions on the first two problem before we move to the next problem? Okay, in the second question, I checked whether our favorite number is unique or not. Then I took the first element in the final array. If the first element is greater than our favorite number, answer is no, otherwise yes. Like that does not hold true. Okay, I will move to the next problem then. Problem D says Sofia and the loss operations. Okay, I will come to the second test case of second problem after the third problem. Looks like a lot of people want to jump to the third problem. Sofia and the loss operation. Sofia has an array of an integers a1 to an. One day he got bored with it, so he decided to sequentially apply m modifications on it. Each modification operation is described by a pair of integers cj, dj, means that the element of the array with index cj should be assigned to dj. That is, perform the assignment a cj equal to dj. After all the modifications sequentially, Sofia discarded the resulting array. Recently, you found an array of n integers b1 to bn. You are interested in whether this is Sofia's array. You know that the values of original array as well as values from d1 to dm. The values c1 to cm turned out to be lost. Is there a sequence of c1 to cm such that sequential application of operations to the array transforms it into b1 to bn? Like let's pick some of the samples first. Like any suggestion which sample should I explain over here? Okay, fourth sample. I will take both first and fourth. I will start with fourth sample first. It says like the original array is 3, 1, 7, 8. Final array we have is 2, 2, 7, 10. And we have 5 values 10, 3, 2, 2, 1. So like the first condition we have is like what are be the indexes where we apply these operations? Like there would be one index where 1 should be applied, right? So like there should exist some index where 1 should be there. And if you look at B, there is no 1 here. So that's why the answer is no. Like this is the necessary condition we have. Because like whatever, like in the worst case, like we can apply all the operations on same index. On same index. So like it's not necessary that this value should exist in B, but one should definitely exist. And like that's why in the fourth sample the answer is no. And like probably like there I had more ideas, but like this is necessary condition, and like that's why the answer is directly no. Okay, people asked for the sixth sample as well. Like I will take sixth sample to give a glimpse of idea. In the sixth sample, the values are 10 to the power 9, 2003, 2003, 2003. And the final values are 2003, 10 to the power 9, 2003, 10 to the power 9. Like why last element? Because in the worst case, let's say we apply all the operations on the same index. Then like for the first m-1 element, they will be overwritten, but the last operation will never be overwritten. So like there should exist some index where the last element is present in B, because it will always be present. And like now here the idea is like let's forget about D first. This 10 to the power 9 was overwritten by 2 to the power 3. So D should have 1 2 to the power 3. This 2 to the power 3 was overwritten by 10 to the power 9. So D should also have 1 10 to the power 9. This is same, so we can skip it. Like if we do nothing here, like the value remains same. This 2003 was also written by 10 to the power 9. So our D should have at least 1 2 to the power 3 and 2 10 to the power 9s. If we have anything less than this, then the answer is no. Because in one operation, if we have let's say 2 to the power 3 and only 10 to the power 9. So in one operation, we would be able to change this, and we would be able to change, like we can probably overwrite here. Wait 1 second. Let's say we have only 10 to the power 9. In that case, we would be only able to overwrite either this or this, but not both. So like D must have 1 to the power 3 and 2 10 to the power 9. That is the minimum we need over here. And like these two are the sufficient conditions as well. For each BI not equal to AI, check if there exists element in D and then delete it. This is the first condition. And the second condition is like DM should be equal to some BI. If these two hold, the answer is yes. If any of these fail, then the answer is no. And like this is the sufficient condition. Now the question is, what about elements present in D but not in B? Like let's take this as an example. Here like we say this is the sequence required. The numbers are 203, 10 to the power 6, 10 to the power 7, 10 to the power 9, 10 to the power 9. Then what we can do is like using this we fix this over here. Using this 2 to the power 3 we fix this. Using this 10 to the power 9 we fix this element. Using this 10 to the power 9 we fix this element. And notice that this is the last element. So what we can do is, like, if we, let's say we replace it at 4th index, then we can also overwrite all these missing elements with at index 4 only. Like, I will give you a dry run example. Again, 2 to the power 3 changes to some 10 to the power 9. 1 of the 2 to the power 3 changes to 10 to the power 9. 1 of the 2 to the power 3 remains 2 to the power 3. 1 10 to the power 9 changes to 2 to the power 3. And now we have element 2 to the power 3, 10 to the power 6. Now we have element 10 to the power 6, 10 to the power 6, 2 to the power 3, 10 to the power 9, 10 to the power 9. First, let's find the position of this element. Like, let's say this is replaced at index row. Like, this is the last element, there should be a place where this exists. And like, now we first try to match the elements here before jumping on the order. So this 10 to the power 9 can be matched here, so it can be at index 2. This 2 to the power 3 can be at index 2. Now the way we will construct is, we will look at where the last element exists, it's at one index. This is not anywhere, so we will replace this 10 to the power 3 with 10 to the power 6 here. This 10 to the power 7 is also not anywhere, so we will also replace it with here only, 10 to the power 7. Now this 2 to the power 3, like this 10 to the power 9 will be replaced with 203. This 10 to the power 9 will go here, this 2 to the power 3 will be replaced with 10 to the power 9. And like, this is the last element, so we can replace it directly with the last element. That's how, like, the sequence criteria is taken here. And like, that is the idea here. Yes, like last element was critical, and like, this is the only conditions I have. Like, you can maintain elements in a multiset. Be careful of how you delete elements in the multisets there. Like, the order does not really matters. Like, last element should exist somewhere, and all the elements we need should exist somewhere. Like, first I created a required array. If values are equal, I don't need anywhere. Otherwise, I should replace the corresponding element to y in the required. If required, like, the count should not be used. If x, now move to all the elements in B. If x exists in B, required dot find. Then, like, we should remove one element from the required. Now, if some of the required elements still remains, like, then we were not able to find, like, the some of the values B which were written, there does not exist an operation with D here, so we should print no. Now we iterate on all the elements to find if it matches with one of the last values. If it matches, print yes, otherwise print no. Like, when I discussed, like, I transformed these two operations in the different conditions. Like, I checked second condition, like, why you need to be careful. Like, in multiset, if there are 5 values equal to 2, then, like, just erase can delete all 5 of them. And like, also be careful with multiset.count as well. So, like, any questions on problem C? Otherwise, I will move to problem D. Okay, next problem. Problem D says GCD sequence. GCD of two numbers is given as the largest integer which divides both of these numbers. For example, GCD 36 and 48 is 12 and GCD 5 and 10 is 5. GCD 7 and 11 is 12. Christiana has an array A consists of exactly n positive integers. She wants to count the GCD of each neighboring pair of integers to get a new array B called GCD sequence. So the element of GCD sequence B will be calculated using formula like GCD of each adjacent element. Determine whether it is possible to remove exactly one number from the array so that the GCD sequence B is non-increasing. That is Bi less than equal to Bi plus 1 always true. For example, let Christian had an array A 26, 12, 3, 48, 36. If she removes 3, then the array becomes 26, 12, 48, 36. And like the GCD of first two elements is 2. GCD of second two element is 6. 3 is not there, so GCD of the third and fourth element would be 12 and 48, 12. And GCD of 48 and 36 is 12. And you can see like this element is increasing because all the values are less than equal to 1. And like if we should print yes if at least one such element exists and no otherwise. Any questions on the problem statement, or like should I explain it by taking some more working examples here? Okay, moving to the solution part. The first thing we need is A1, A2, A3. So on up till AN. And let's say we want to remove this AN. Notice that the sequence formed by these elements is still same. Similarly, the sequence GCD of here is also same. So what we really need is we can use some prefix, some idea, prefix and suffix, GCD and increasing count sequence idea. Prefix K denotes it has two elements. It's a pair, first and second. Pref K like basically I have A1, A2, A3, A4, A5, A6, A7. I will first create a sequence of GCD of 1 and 2, GCD of 2 and 3, GCD of 3 and 4, GCD of 4 and 5, GCD of 6 and 7, 6 and 5 and 6, and so on. Like first element of the pair, and like second element denotes like the sequence formed so far is increasing or not. Like nothing is there, so it should be true. If this holds, then it should be true. Let's say here this holds, so the sequence will start becoming false from now onwards. This way, by only looking at I minus 1, we will be able to check in order 1 if like these elements are increasing or not. And similarly thing we can do for the suffix as well. Any questions on this idea first before we try to see what happens when we remove this element here? Repeat, yeah. I am maintaining a pair of prefix. Like let's say not just pair, just a Boolean variable. For checking if A1 to AK forms increasing sequence of B or not. Looks fine, right? And like question is like how do I calculate all these values? Let's say I have A1, A2, A3, A4, A5, A6 and so on. The value here would be true because there are no elements in B. Value here would be true because there is only one element in B. When we want to check for like some random element AK, BK is true if BK minus 1 is true. That denotes like all the elements before this element were true, and GCD of AK comma AK minus 1 is greater than equal to GCD of AK minus 2 comma AK minus 1. So like I can take some examples as well. Like let's pick 1, 6, 7, 12, 6. One, 6, 11. 11 does not look good. 12. So on. If you look at only this element, B would be empty here. So like the sequence would definitely be increasing. In this case, B will only contain GCD of 1 and 6, which would be 1. So like the B is in increasing order. Here like B would be GCD of first two element, GCD of second two element. It's still increasing. This is true. Here like B would be like 1, 6 and again 6. It's also in increasing order. Here when we add 36, 1, 6, 6, 18. This is also in increasing order. Now let's say we have 9 here. Here like GCD becomes 1, 6, 6, 18, 9. And here like B is no longer increasing here. Now if you even add like 99 here, the sequence would be 1, 6, 6, 18, 9, 9, and if you add like 990, like that, it would be 919 also. But no longer what happens, like B is no longer true, so we can mark everything as false. Like we can basically find the first index up till which B is increasing, and then B stops becoming false. Similarly, we can find from the ending the first index, last index when B starts becoming false. And if we have those two variables, using them we can check if we take only first I minus element, whether the sequence would be increasing or not. Any questions on this one? Like my idea is like when I delete AI, the sequence generated using A1 to AI should be increasing. Like sequence generated using AI plus 1 to AN should be decreasing or basically increasing, like the way we look at it. And then like the case would be like the fix up case, when like we have a I minus 2, a I minus 1, a I plus 1, and a I plus 2. And we will have to check whether this is also an increasing sequence only. Can't we directly remove the element where GCD is increasing? I think we can do that as well. Like we can first find like the first element when the B is no longer increasing. We delete it and we try again. If the answer is yes, we print yes, otherwise we print no. And like in fact that is a pretty neat solution. My solution involved a lot of things. Thanks, Aryan. Yeah, I will repeat like simplified approach. Like simplified approach, let's forget whatever I discussed so far. Let's create V first. Now find the index where like B decreases. Like for example, like B can be 1, 6, 6, 9, 5. And then something else happen. 12, something like that. So what we can do is like this 5 would be 1, 2, 3, 4, 5, 6. This 5 would be equal to A5, comma A6. This 9 would be because of A4, A5, and something on. So my idea is we just need to try this deleting A4, A5, and A6. If deleting any of them gives us an increasing sequence, we should be good. Otherwise, we are not good. So we are checking 3 deletions here, like A4, A5, A6. And yeah, like that is the critical idea. Like my prefix suffix was the idea. And like let me first check if this works or not. Like prima facie it looks like it should work. Like why delete 3? Like it's just to be more cautious about it. Like probably we can prove that we don't need 3 elements. Because here the problematic element are 9 and 5. At least one of them has to go. So like 9 can go because of A4, A5. 5 can go because of A5, A6. Like let me check like if anyone has coded it or not. Like if basically no one coded like deleting one element, then I will revert back to my old approach. Like seems like pretty much everyone had a check of something what I did there. Okay, yeah, like finally someone coded deleting one element. So like what is the approach? If you delete the last element, if it's true, print yes. Otherwise, the first time when some element exists, you try out all 3, 4 elements and that's good. Yeah, like Discord server URL, I will fix it. Like not really sure like why it has expired, but yeah. So like this is the approach and like this looks much better. Yeah, like I can explain this implementation. Like I will probably start coding first, and then we can go towards like why this works. I am at problem D. First, I need to check an element. Does the sequence becomes increasing if we delete IDX index? Like this is the original sequence. We should skip this index. Like now, like if we delete IDX index, this is what our appends become. Now we need B. So like we can increase pairwise GCD of. And now we can check if B is equal to sorted sequence, then the answer is yes. Like this is algorithm which checks if we remove IDX index, whether our code would be IDX or not. Like let's just write get B as well. It takes an array A and it gives us the corresponding array B. Looks fine, right? Now what I will do is, first I will create B sequence using A. Like first thing is, if we remove the last element, like let's not just go with the last element. Let's first find B. And find the first time where like we must delete any element. So like we can first try deleting first and the last element. If any of them works, we are good. If this does not work, then definitely like there is one pair of element where if Bj is less than equal to Bj plus 1, then this is not a conflicting pair. Otherwise, like Bj is less than Bj plus 1 is less than Bj. So one of Bj plus 1 or Bj must be deleted. Any questions so far here? Now the idea is Bj plus 1 is GCD of Aj plus 1 and Aj plus 2. And Bj is GCD of Aj and Aj plus 1. So for we must delete one of the element from here. Invalid index are not allowed. And at last, like, we can check. Like, this should solve the problem here. Yeah, I will come back to the code again. Like, I'm just checking if there are no implementation mistakes here. If it gets an AC, I will come back to the code again. Looks like some lag on Codeforces. Yes, got an AC. Okay, the idea is I will first jump onto the solution again. First idea is like write function which deletes a, like, check if deleting 0 index works and -1 index works. If any of them gives us an increasing sequence B, we print yes. Otherwise, we find B sequence B, which would be GCD of pairwise of elements here. Now, like B1 would be like this: B0, B1, B2, B3, B4, B5, and so on. Like this would be GCD of index A0, A1. This is GCD of index A1, A2. GCD of A2, A3, A3, A4, A4, A5, A5, A6. Looks fine, right? Any questions so far? Check if deleting 0 works. Check if deleting n-1 works. Otherwise, find the sequence B of all the elements. And like this is how B looks like. Any questions so far here? Yeah. Now let's say B looks like this. This is greater than equal to this. This is greater than equal to this. And now this happens. This is the first time like the sequence B order mismatches. And like then something else is there. Then what we need is either B3 must be deleted or B4 must be deleted and it must be replaced with some other elements. Because if we don't delete B3 and B4, then like B3 greater than B4 will always be there. And how do we delete B3, B4? To delete B3, B4, we can delete A3, A4. And to delete B4, we can delete A4, A5. So our solution reduces to check if deleting A3 or A4 or A5 works. If any of them gives, no, we don't have to delete both, we will be able to delete only one of them, or we can probably delete both as well. The main thing is at least one of them must be deleted. And like it's not necessary that deleting both can give us some other order as well, create other problems as well. So we can try checking delete one of these 3 elements. If deleting any, like there would be a counter test case where deleting only A3, A4 will give us the bad example. Like I will give you an example. 2010. This gives me 20. This gives me 10. Here if I delete 10, it's fine. Like overall GCD is 20. If we take 20, 10, 5. Here this GCD gives me 10. This gives me 5. And let's say like the GCD of 20 and like 20 is also here. So here we must delete 10 here. That's a 20, 25. GCD here is 20. GCD here is 5. And let's say 20 is also here. So GCD here is 20. If you delete this or this, nothing happens because like 20 to 25 will always be there. Here like you must delete 5 here so that this element goes away. Like take this array 20, 20, 25, 100, 100. This gives us 20. This gives us 20. This gives us 5. This gives us 5. This gives us 100. And if here if we delete this 5 goes away and it gets replaced with 20. And that is the valid solution. So here like just trying out these two will not be enough. And like that is the idea. So like we must check 3 different elements. So like now if I check the solution, I have this method which deletes this index. Like I have this element which takes an A, gives us the element B. So like I first remove I create an array A by removing IDX index. Then I try to get B index, and then I see how does the sorted sequence look like. If both of them are equal to B, then B is sorted. And here like now like if it's fine, it's good. Otherwise if Bj is less than Bj plus 1, then like one of these must be deleted. Bj is because of Aj plus 1 and Aj plus 2, and Bj is because of Bj and Bj plus 2. Like I can just check, like I am hopeful like just 2 elements should not be enough, but let's just check it. Why no I have to? Because I don't know how to solve it. Like I will probably look at like it fails on the very first sample only. 12th. You can try out working on this example and see like why like the last element would be enough. Like I will probably move to problem E now. Any questions on this problem so far? Like we first and last, like if B ends up increasing, then deleting any of them will work. Problem E says permutation of rows and columns. It says we are given two matrices. Every element of matrix is different. And like we can take any two columns and we can swap those two columns, or we can take any two rows and we can swap those rows. It says we are given two matrices A and B. Can we get A from B by following some operations? Like for example, let's say we have 1, 5, 9, 6, 12, 10, 4, 8, 7, 11, 3, 2. Like I am looking for an idea. Okay, the example which I was copying is pretty much. Create some. Six, 4, 2, 7, 8, 3. Let's say we have these two matrices. The first idea is, if we compare set of rows, like if we swap them, like first if we do any column operations, if we do column operations, the sequence of elements in the row changes. But it does not remove, it does not shuffles element, it does not elements from other row. To summarize again, let's say if we swap these two elements, shift over. Even after this swapping, the first column will have 159. The order will change, but 159 will be there. Similarly, the second row will have 642 and it will have 642. The order can change based on what rows we are supplying. And similarly, 387, like 38, like if we swap columns, last row will have 387 and 387 only. So if we ignore order of each set of if we ignore order of elements in a row, then for each row here there should be a corresponding element with same unordered element. Like for example, here if you look at it, this 951 has 951 in the other row. The order is shuffled, but the corresponding row is there. And like for this, like there is one another row with the same elements in it. And for this, and you can see like this is the necessary condition which must happen if by chance A and B can be formed by this sequence of operations. Any questions on this one? Like how do we check this? I will come back to it later, but this must happen. Like, do you agree with it? Like when you do some row operations, you cannot jump element from one row and move it to the other row. So like if you ignore the order of elements in each row, then like swapping columns does not change anything there. So like for the first row, like if first row has 159, there should exist some row in B which has 159. If the last row has 387, then there should exist some row which has 387. The order doesn't matter, but there should exist something. Any questions on this one? Hello, any questions on this one before? And now we can say the same thing for columns as well. If you look at each column, then if you ignore the order of elements in that column, then whatever row operation you do, that cannot remove element from one column and move it to the other column. So for each column, there must exist a column which has same elements there. And if we check these two conditions separately, then print if both of them holds, print yes, otherwise print no. And like that is what I did. I did not bother proving this part. Do the same check for column, and if both of them give us true, then print yes, otherwise no. So like I will jump onto the code ones. If check rows, print yes, else print no. For each row, like find row A, row B, and if we want to ignore rows and columns, we can say that all the elements in sorted order must be equal. And now if we also want to now if we want to ignore the columns, like each column should have same number of elements irrespective of their order is. Like this is the one way you can do this. And if we want to check columns, like this is the sufficient check. We can do this. This works. And like you can also use Jorbit hashing as well. Like the other way to do it fast would be you can also use Jorbit hashing. That's what I did in the contest. Any questions on this one? Like I did not bother proving why this works. Just that I realized this must hold. And that was the idea. Any questions on problem E before we move to F1 and G? Okay, I will move to problem F1 then. The idea is like this is the easy version. Like basically, if we have some plots like this, and like we own this cell 5 comma 1, and like we start from some cell, we go top left to top right. We start from somewhere here, and we want to end somewhere here, and it asks us like how many area we can get for ourselves. Here in the problem statement, it says like this area is blocked for us. 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 This is our area. And like we start somewhere from here and we will end somewhere here. And what is the area we can have on our side? Here in this case, it says like if we take this path, then every area on this side will be our area. And we should first count this area for us. So any questions on the problem statement first? On the first part of the problem statement? And then it says like for each block region like this, E will work on every matrix, right? Not just permutation. If even if numbers, no, we cannot say that. Like I am not really 100% sure. Like permutation ensures like each element has the final ending element there. And like there may be some mix-ups if it's not a permutation. Like probably I will have to check the proof and then only I will be able to say like repeat the like and now like coming back like looking back like repeat might work but there can exist some like not really sure like I will check and respond. So the first part of the problem statement is this, and let's see like how can we find the maximum area. Like we have this as the argument. So let's start with the last row and see what is the maximum distance we can go here. Let's say this cell is blocked, so the maximum distance we can go here is this. Now move to one row up. Here we are, and let's say nothing is blocked here. Then we can also take these 4 parts here, because in that case our root would be come anywhere here and then go down. And let's say now this cell is blocked. So like this is the only area where we can come from the top. And let's say now this is blocked. although these are allowed, but if we go via this route, then this is the block cell and we are not allowed to have this cell in our directory here. So like we must come via this route only. So the critical idea is start from the last row, find what is the maximum area we can have. Now look at all the in the row just above it and like all the area what we have taken so far. See like can we take all of them? If not, then what up to what we can take, and then we can keep decreasing our mean and we can go ahead over here. And like that would be one way using which we would be able to find our answers here. So like maximum column, like I have a variable which because numbers are up to 1 in 9, I maintained a map maximum column up to which we can go. And any element which is not present in this, we can assume we can go up to n minus 1. Now I move in the decreasing order. And like what was the previous column up to which I can go to the maximum element. So if I am outside, then I can go up to m as well. And like this is the first cell which is blocked in the current row. So like first I take some of this. Like for example, I was go up to this part and this one was blocked. Nothing was blocked here. Nothing is blocked here. Nothing is blocked here. And then a row here is blocked. So what I can say is for my answer, I can definitely take this region. So I first add this to my answer. What was the previous mean we were able to, like the number of rows and up to what we can take. And now there are two cases. If the block, it is blocked here, then we can start by saying like we can take everything before here. So like we do not decrease the maximum area we can go up to. And like if this is the blocked area, then the maximum over here we can go up to would be this part. So we replace that the maximum length we can go over here. Like let's keep the variable name maximum. And like the previous row which I have processed. So that way I would be able to find like the total area. What the neat thing I did was I also added -1 row, so I take answer up to 0th row. Any questions on finding answer so far? Any questions how we will find the area which we own? Like regarding repeated element, what I see is like this is necessary condition but may not be sufficient. So like once we know the area, now like let's look at this figure again. Here like this was the time when we decreased our area. So if we remove this area, we can definitely go to this region here. Similarly, this was the area which reduced the area which we can go. Like if you look at it, like this was the first time when our possible area which we can take reduced. So if we remove this, then we would be definitely able to take this element. Similarly, this was the time when our possible area we can take got reduced. So if we remove this element, we would be able to definitely take this cell here. So if we keep a track of where we have reduced the length, then if we remove any of this cell, like we would definitely be able to take that cell there. So like the answer is 1 if it's the cell which reduced our length, otherwise the answer is 0 because that's not helping anything. So like whenever I reduce length, I inserted a set, added a row there. And what I am doing is like I am checking like whether that element is in my reduced set or not. If yes, print 1, otherwise print 1. And like that is the solution for F1. Like F2 asks, find for each element if we delete that, what is the area which increases. And like it pretty much took a lot of time and like I was not able to put all the pieces on time to solve that problem. So I will skip F2 and like I will go to problem G then. Any questions on this one before we move next? So I will mostly move to problem G then. Problem G is a bit tricky one. Problem G says we have a graph first. Where each row has some weight. And there are some queries. One query changes each wi to given some y value, like basically takes XOR of each element. And like the other query is like we have been given a node u and some edge weight x, and we can hang it, and the other end of this node can be any node here. What is the maximum weight of cycle we can get? Maximum XOR of cycle. And like we have to print like here, like if you connect this, then we need XOR of edges on this cycle. If we connect this, then we need XOR of these three edges. Any questions on the problem statement? Then the next idea is, any questions on the problem statement? Okay, I will move to the next part. Let's forget query one exists. And also self loops are allowed. So basically we can create u from u of length x, and then we can take x as a cycle length. Let's solve this problem first, and then we will look for optimization. And like let's pick some element as root. And for each element, let's call PVS XOR of edges on path from root to V. So here like the XOR would be these two, XOR of these two nodes. Here like for this node like XOR would be XOR on this path. And for this node like the XOR would be on this path. Looks fine, right? Now let's see what happens if we add an edge here. Let's call it V, PV, PU. So what we need is like the XOR on this cycle would be, note that this edge has, if we XOR PU, PV, this edge has already been taken twice. So this is essentially XOR of PU VX. Like this is the XOR of cycle. Add edge of length X between V and U. Hey, hi Vidya. And like the credit goes to Vidya for designing the thumbnails we have. So like this is the critical observation, because whatever be the LCA here, everything from LCA to root is already counted twice when you take PU PV. Any questions on this observation first? And like once we know this, what we need is like only variable here is PU we have. We know V, we know X. So we know PV and we also know X. So like we want to find for each value U which PU or which PU gives us the maximum value. And like so what happens is like given an array P, we have some other fixed value P and we want to find what is the max or we can get if we take one value from this array. Y, which in our case would be PV XOR X. Find maximum value of PV U, like basically PI XOR Y. And like this thing can be done using try. Like it has appeared a lot of time and I will probably skip this part. Like in fact Ashish group has a lot of problem. किसी दिन ये क्वेश्चन जान लेकर आएंगे. Agreed. Like you can check out codes here. Like these are the sample problems which you can try out over here. In fact, like this is the old Codeforces problem. Like I will skip this part. Like how given an array and given one value, find the value. Like author has gone out of stories about Vasilia. Q queries and a multiset A initially contain only integer 0. There are three types of value. Add integer x to multiset. Remove one occurrence of integer x from A. It is guaranteed that at least one occurrence occurs. Given an integer x, we need to compute maximum value of x and any one element from y, and this value we should print it. And like this is essentially what we need here. So like a homework problem to try out for. And like the idea is using try. I will skip how to do it using try, and you can probably refer this editorial. And a lot of YouTube videos are already there. Now our problem reduces to like how do we solve for type 1 queries. Like first, like self loop is not allowed. Like self loop is not allowed. Self loop is also not allowed. Like that was caught in sample as well. One second, looks like my whiteboard is. Where were we? Just give me a minute. Like it's not. It's not picking up. Okay, I think it should work. Like I will probably switch the board again. First, self loop are not allowed. And like in our problem statement, it's possible that AV or PV or PV. X gives us the maximum. And like this in fact fails. Like see U not equal to V is allowed. So the way we can do is like we can run two for loops. We insert like solve offline. Answer all queries. Then push AI in try. So this way we would be able to find answer for all the values of P1 up to max with P1 up to Pi minus 1. And then we can go in the reverse order like clear try. For I equal to n to 1 for all queries related to I, find answer. This way we would be able to find answer for all I1 to up to Pn. Like, explanation sucks, bro. Watch TL1. Like, I am not forcing anyone to watch the submission here. And thanks for tuning in, by the way. Like, if someone explains much better than me, then you can definitely reach out. Go there. This way, like using two loops, forward and reverse, we would be able to deal with the self loop either. We can remove self loop problem. And now the problem is because of like type first. Now like type 1 queries are also there. So like critical observation for the type 1 queries, let's say if the cycle length is even, like we can keep a hash of like what is the XOR of edges so far. Of all edges so far. And like now if you see like your length is 5, then like we have taken completed XOR of all the elements with same element so far. And in this case, like the edge XOR is definitely like cycle is even length, odd length, then type 1 queries does not impact answer. And if it's type 2 query, then you can see like all XORs cancel out and only one time XOR remains. So like we can basically group each element by height. We can separately deal with taking XOR with odd height, and we can separately take XOR with even height. That way for like two elements are on same height, then cycle length would be an odd length, and like first type 1 queries does not impact us. And if two elements are at different height, then like type 1 queries is equivalent to just changing XOR for only one edge, and we can do it for X. So like I will probably jump on to the code for 5 minutes and then we can deal with it. First I have a XOR, like one DFS to find all the values from root to that node. Like now P contains the height of that node, whether it's odd or even. And what is the XOR from root to that node? Like offline queries, if we maintain a separate variable df, which we should XOR all the edges before taking a query. So if it's type 1 query, we simply keep a copy of it and we move. And when it's v and x, we said for v, we have query number QR, like trying to solve offline. What was the value of type 1 queries so far, and what is the value of edge added so far? Now to ignore the self loop problem, all the edges which are at same height as current node I, we process all the queries and then we insert current node into the trie. We remove the trie, then we move in descending order for all the nodes which we have from like I plus 1 to n, which are at same height. Find the max XOR of all the edges so far. And like now we also look at the other height. For all the nodes which are at a different height, take XOR with value of current node, value of x, and whatever the value of sum of all the DFs we had at that point of time. And like taking maximum for each query and like print max at each query, and that should solve our problem. And like essentially like that was pretty much the solution for this problem. And like I think I will end my stream with it. This is good article on how to stop. Is there a good article? Like, yeah, like I think like problem C and D are getting hacked due to hash map collisions. This is blog by Neil, which explains about C++. It says like hashing all the element is as simple as writing a code like this, where if, and then it also says how we can avoid unordered hashing as well. And a similar blog for Python exists. Like method is similar and like I'm not sure, like when I'm checking, like it says like Discord server, like can you say like which Discord server link expert? Like there are multiple links. I will replace the one on YouTube, but like when I tried, it looked like it was working. Or it may be in the channel description as well. Like, yeah, I will try to do and fix it. Unordered map. Good article. I think the same article says. And like, why is he getting at? But yeah, maybe like summer vacation. Like, I would say do both of them. Like, there is no reason to only choose CP or web development. Why can't you do both of them? भैया मेरी रेटिंग 1130 है अभी ये 1.5 महीने से डेली सीपी कर रहा हूँ अराउंड 150 क्वेश्चंस की एनी टिप्स टू इंक्रीज रेटिंग like this is one of the most frequently asked questions and like I have in fact answered it on my Discord server. Like if you join the Discord server, there is channel roadmap to RAD in 2 minutes. Like no one becomes RAD, but it essentially says like what I did when I was expert or below, what I did when I tried to reach master, and so on. So you can check it out. And I think that solves doubt. Yeah, like in an ordered map, there are collisions, and like that is the reason. So any other questions before we call it a day today? Like C was definitely hard for Div 3, and like F2 I wasn't even able to solve it in the context of. Like these CLEs are mostly collision hacks only. Looks like someone is hacking Jingli. Okay, he did something smart here. Looks like what he did was like all the swaps that should be made for column, like he tried to fix the first row and first column. And if after fixing the first row and first column, if we get the correct answer, then print yes, otherwise print no. Like this is also neat solution. Like basically fix first row, first column, and and that is where like if you allow equal element, then it's possible that other solutions also exist. Yeah, like tips, like you can check the Discord server. Like there is a channel roadmap to read there where I explained like what I did when I was below expert, what I did when I tried to reach candidate master, and what I did when I was trying to go to grandmaster and so. And during summer vacation, grind CP or do other stuff. Like my answer is like there is no reason to only choose CP or some development or something. Like summer vacation is the time when you don't have college or anything and you can try out all the stuff there. And like any other questions in the chat, like I will wait for 2 more minutes and then I will call it a day. So like thanks a lot everyone for joining today. And I think I will end the stream now.